Hello, IB Physics. Today in this quiz, actually it'll be two quizzes, we're going to be taking some notes and doing some practice together. And so I've formatted this in this quiz thing so that you can like follow along and check your work, and I can also know your progress. A little bit different than what I've done before, but I'm hoping that it helps. So you're going to need a worksheet that I have for you on paper. It's in your binder, 2.5 and 2.6 in your binder. They look like this. This is the front side of 2.5. This is the front side of 2.6. If the numbers didn't copy very well, I'm sorry, but it's 2.5. It looks like this. 2.6 looks like this, and they have two sides to them. So there's actually 4 pages we're going to be doing. This first quiz is going to cover part 1, where we're going to look at these graphs, and then we're going to do the back side of this and a little bit of these practice problems. And then the second quiz, which is obviously not this one that you're in, will be about part 2, where we're looking at going from velocity time graphs to position time graphs. So you're going to want to follow along on paper. You'll answer some quiz questions about these problems, and I'll also walk you through some things. So we're going to start off by looking at this graph. This is graph number 1, and it says answer the questions about each graph below. So I'm going to help walk you through graph number 1, and you can go ahead and answer these questions along with me. Excellent. So looking at this graph, this is again graph 1, the same as on your worksheet. It asks, what is the horizontal axis label? The horizontal, that means the horizon-like one, and that would be time in seconds. So I'd write down time. What is the vertical axis label? Vertical means up and down. Oh, that's position. You got it. Number 1 and 2, pretty quick. Number 3 says, what does each of the points mean? So it says for A, at a time of 1 second, so 1 second, the object is at a position of 2 meters. So here's A at 2 meters. Okay, cool. That's pretty easy. So then we can look at B, and we would say something like at 3 seconds, because B is at 3 seconds, the object is at 4 meters. And then for C, we would say now we're at 5 seconds, and the object is at a position of still 4 meters. And then D is at 8 seconds, and that looks like, I don't know, 3 point something, maybe 3.3 or something. Okay, so we've figured out what each point is telling us about the position, and hopefully you've recorded this down on your paper. I've recorded it on my paper as well. So here I've got time, position. Oh, look, I made a mistake. D is not at 5 seconds. D is at 8 seconds. It's at a position of like 3.3. If you said 3.4, 3.2, you know, no big deal. It's a little bit hard to see this because I made the lines really fat so that they would print really well. So you can see them very clearly, but you can't exactly see them very precisely. There's actually some interesting uncertainty principle implications there, but I won't get into that because that doesn't matter right now. So let's move forward with saying, what is the unit of the slope on this graph? Oh, the slope. Do you remember how to find slope or what slope is? Because you've learned about slope before. I know you have, for sure. And maybe when you think of slope, you think of something like rise over run, and that's pretty useful. Probably you could use the idea of rise over run to figure out what the units are here. But I happen to know that slope is going to come back over and over again for us. And it says, what is the value of the slope? Whew. So we're going to have to know a fair bit about slope and how to find it. So I stole this nice picture from the Googles. And you, again, remember it probably as rise over run. So rise means the change in the y, and run means the change in the x-axis. So we have change in y over change in x. Or we can think of this in point slope formula way. And if you don't know how to calculate slope just off the top of your head, you might want to jot down the point slope formula right here, where we say y2 minus y1 over x2 minus x1. and that's for 2 points. So here's 0.1, here's 0.2. It doesn't actually matter which one is 0.1 or 0.2. You just have to make sure to keep it consistent. And so this is how we can calculate slope. So we can go ahead and look at our graph, and its rise is in meters and its run is in seconds. So that means that the slope of the graph will be in meters per second. Meters per second. That should sound a little bit familiar to you, a little bit like a unit we might use in class to measure something. So we want to continue on. 5 says, what is the value of the slope at each of the points? So here I've calculated the slope for you. So for A, I'm actually looking at the beginning of the little line that is A and the little end of the line that is A. So at the beginning, that's 0, 0. The end is over 2, up 4. You could have done over 1, up 2. You could have done over 1. But anyway, you get the point. I picked points that were easy to look at. So I used point slope formula here. 2 meters divided by 2 seconds equals 2 meters per second. Then let's do the same thing for B. So pause the video if you don't want me to spoil B for you. Okay, so in B, again, I'm going to start with this point right here, over 2 seconds, up 4 meters. And then I'm also going to use point B as the other point. So that's over 3 seconds, up 4 meters. So I've written that down here again, point slope formula way. That's going to be 0 meters divided by 2 seconds, and that actually equals 0 meters per second. And that might make sense to you with what you know about slopes, because like the line is flat, so that means that the slope is 0. So pretty sweet. So take a moment and try answering C and D on your paper and show your calculations, show your work. And then you're actually going to write your answers in below. There's a question. That's what this question is. So you can go ahead and jot those down now that you've figured them out. And you might want to pause the video and then come back. So then we want to go ahead and in part 6, we're trying to interpret what the slope is telling us. So a slope of 2 meters per second means that for each additional second that passes, so per second, means for each additional second that passes, the position increases by 2 meters. And this makes sense if we look at our graph. For every second that goes forward, here's 1 second, the position has gone from 0 up to 2. And then from 1 to 2 seconds, that's 1 second has passed, the position has gone from 2 up to 4. And then we have kind of a weird thing happening, but the line could continue and keep on doing that exact same thing, increasing by 2 meters every second. So then I would go ahead and describe at B, for each second that passes, the position stays the same. That's what a slope of 0 meters per second means. It means that the position is not changing. So I could actually have written, the position is not changing equally well, or I could say that the position changes by 0 meters. That would all be saying the same thing. It's essentially telling us that the object is standing still. Take a moment and try doing C and D in your notes paper, and answering number 7, where you're really trying to describe what is happening in this situation in a couple of sentences. So maybe 1 or 2 sentences. So you can describe where we start, what the velocity is, then what happens. Awesome. So hopefully you have done number 6 and number 7 on your notes paper. And in the next question, you're actually going to be working on this next graph. So the graph analysis questions, I'm not going to walk you through in a video like I've just been doing, but you are going to answer them and you'll be able to figure out which questions you get right and which questions you get wrong by looking back at your quiz submissions. Let me know if you're struggling or have any questions, and do the very best you can.